Hello, flat earthers are fairly strange in their beliefs, and all the latest rage seems to be around trying to prove how the sextant doesn't work on a globe, that somehow because they think that we haven't proved the radius of the earth, or that we can't get a geometric horizon because it's only an apparent horizon because of the atmosphere, etc., 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 that there is no radius or curvature of the earth, and therefore sextants work, and in their minds the earth is not a globe, so QED, earth is flat, etc. So I thought I was going to tackle that issue in this video. This is going to be yet another video on my flat earth excuses series. And what I've done was I've chosen a few sample locations on the earth with some sample stars. And the first place that I chose was Anchorage, Alaska, which is slated to be in several days from now, and I've marked several stars that should be visible in the sky at that time. I've also got a couple of other places I'm going to show you as well. I'm only going to focus on Anchorage in stellarium, but the other ones are going to be pretty much the same. If I look up the star Thuban should be at an altitude of about 35 degrees 34 minutes. And so what I've done was I've taken my sky watching app that I was developing, and I decided to add a mode that simulates the distance from where the star is over a GP based on the angle measured. So here we can see that Thuban has an altitude of 35.55 degrees, and 0.55 degrees would be somewhere around 35 minutes or thereabouts, which would be closer to what we have here. And I haven't heard a flat earther try to disprove the 69 miles per degree rule. And so if we measure the star at 35.55 degrees, you subtract that from 90 degrees, and you're going to be left with about 54 point some degrees, and then you multiply that, and I'm using kilometers in this case, which works out to be about 111 kilometers per degree. So from Anchorage to the ground where Thuban is directly overhead should be 6,053 kilometers or thereabouts. And this would be the geolocation on Earth where the star should be directly overhead. And I've done the same for the other stars as well. So let's try Markab next. 36.21, 36.23. Let's try Menkar, and Menkar has 30.97. So as you can see, they're very close. So what would happen if we drew a circle that was equidistant around the Earth from the GP of where that star was directly overhead? This one appears fairly circular, but you can see that some of these appear to be slightly misshapen. And you can see that all three have a central point where they intersect with each other. And if I change the time, you can see it doesn't really matter where they are. This one here just disappeared. That means that it has gone below 0 degrees altitude. Flat earthers are not happy with the fact that these don't appear particularly circular. So what would happen if we modeled it on a flat earth? So if the ground is flat, as they say, and the star appears directly overhead of this point, then if we map out the distance from Anchorage to this point and figure out that that is, at this point, 5,780 kilometers, then we can draw a circle around that GP that matches that distance. So as you can see, they all appear circular. And so far, it doesn't seem too bad if I change the time, except some of these you can see are no longer touching my current observation point. So Markab's outer perimeter that matches 7,435 kilometers isn't even reaching Anchorage, Alaska. So this is a bit of a problem. Whether I map out the distance that it should be around that star for the flat Earth or for the globe Earth, I took each of those geo-coordinates that I computed, either for the globe Earth or for the flat Earth, and I created some KML files. And this is what it looks like when I project the globe, and that is the GP of Mankar. And I can go over here, and that would be the GP of Markab. And finally, this would be the GP of Thuban. These could very easily be confirmed by anybody on the ground looking straight up. And so what does it look like on the globe? Well, if I rotate the spherical Earth so that the yellow line for Thuban appears straight, you can see that it goes past Anchorage, Alaska. And if I do the same thing again for the next one, Mankar, it's also a nice straight line. And last but not least, for Markab, it's also a straight line when viewed from this angle. And if we compare what that looks like modeled on a flat Earth, the three don't intersect very well at all, and there's some serious deformation at certain latitudes. So I decided to do something similar again for a different location on Earth, and I decided to pick Windhoek in Namibia. So once again, if I go around sunset, you can see that on a globe Earth model, all three stars are equidistant to my point of observation, and I can change the time, and you can see that they all align. If I look at the flat Earth, things get a little bit worse. So each one does at some point eventually, when it gets to the longitude of Windhoek, the distance to it happens to match the observed distance, but the three do not intersect at all. Once again, on a globe Earth, all three lines intersect the same point in space, and on the other side, they continue to be straight lines. If I compare that with the flat Earth model, it becomes very twisted, and they don't come anywhere near Namibia. Finally, the last location I thought I would examine like this is Sydney, Australia. Just like the other two locations, if I map the points equidistant on a globe with a radius measured in the distance between the GP of each of the stars and Sydney, all three stars in question intersect a common point in Sydney. And yet, if I try the same thing modeling the flat Earth, some of these are not even close at all. In fact, what's interesting is that the GP of Peacock for about 4 o'clock in the morning this time has gone past Africa and is heading towards South America. And yet, if you are high enough, you should still see Peacock, not to the north as indicated here, but it would be south. So what does this look like when we map it on a globe? First are all of the points that intersect Sydney just fine. But when we try to map the flat Earth, there's a couple that are trying, but this one isn't anywhere even close. And just for reference, that is where Peacock is, looking towards the South Pole, towards Antarctica, the same Antarctica that South America sees, and the same South Pole that South Africa sees. So there you have it. Not only do I just talk about sextants, I actually go and get the measurements from various stars. Using the elevation to that star, I'm able to compute a distance to the GP where that star is supposed to be. And doing all of that math shows that flat earthers just make excuses trying to explain why they don't believe that the earth is a globe, and therefore why they want to reject the fact that sextants work on a globe and really don't work on a flat earth. So that's going to be it for now. Thank you for watching. If you made it this far, thank you very much. I would appreciate a thumbs up, usual comment, etc. And I'm going to see you again in another video soon enough. So bye for now.